ನೀವೇನು ರಿಸರ್ಚ್ ಫೈಂಡಿಂಗ್ಸ್ ಏನೇನು ಬಂದಿದ್ದಾವೆ, ಸೊ ಇಫ್ ಪಾಸಿಬಲ್ ಅದರಲ್ಲಿ ಎಷ್ಟಾಗಿದೆ ಅಷ್ಟು ನಾನು ಅದನ್ನ ಶೇರ್ ಮಾಡಕ್ಕೆ ಟ್ರೈ ಮಾಡ್ತಾ ಇದ್ದೀನಿ. ಅಂಡ್ ರಿಗಾರ್ಡಿಂಗ್ ದ ಪ್ರೆಸೆಂಟೇಷನ್ಸ್ ಆಲ್ರೆಡಿ ಈಗ ಏನು ಲಿಯೋ ಅವರು ಏನು ಪ್ರೆಸೆಂಟ್ ಮಾಡಿದ್ದಾರೆ ಆಲ್ಮೋಸ್ಟ್ ಸ್ವಲ್ಪ ಓವರ್ಲ್ಯಾಪಿಂಗ್ ಅನಿಸ್ಬೋದು, ಬಿಕಾಸ್ ದ ಅಪ್ಲಿಕೇಶನ್ಸ್ ಐ ಆಮ್ ಆಲ್ಸೋ ಟಾಕಿಂಗ್ ದ ಸೇಮ್ ಥಿಂಗ್. ಇಲ್ಲಿ ಕೂಡ ಅದೇ ತರ ಇದೆ, ಓವರ್ಲ್ಯಾಪಿಂಗ್ ಆಗಿದೆ. ಬಟ್ ಐ ಟ್ರೈ ಟು ಆಡ್ ಸಮ್ ಅಡಿಷನಲ್ ಇನ್ಫಾರ್ಮೇಶನ್ಸ್ ಅಂಡ್ what are the basic things we should know, so before going for purchasing a drone or working with a drone. So whatever the idea I have collected, so as a team we have collected at University of Agriculture, just I want to share those things. So first of all, just I want to have a glance that why in the morning session we have seen that many of our guests has been boasting over India, so that why the India is so great in the whole world. So we know already these things. That is what is our position. That is in almost all in any production, either agricultural productions. It may be a food grades, it may be the other applications or the other commodities. So India stands among the top 3. Okay, so that's why the whatever the technologies that needs to be introduced, so it will be more effective and the outcome will be more whenever it has been successfully introduced in our Indian scenario. So that's why, and at the same time, and we are also one of the fourth largest producer of the agrochemicals and the largest users of the agrochemicals. It shows that how drastically or how much the chemicals we are going to induce in our environment. So there should be some of the things we need to develop, we need to study, so that what are the chances are there to reduce the applications of these chemicals. So those ways needs to be find out. And regarding the food grain production, so of course, year by year it goes on increasing, and in the current year we are expecting that around it will be around 315 billion tons of the food grains that is going to be produced. And so this is more important. That is the as an only to the 10th largest arable land resource in the world. So we can find 15 of the major agroclimatic regions out of 20 in our India. So it's a very vast environment we are having. That's why we are having a variety of crops that are very suitable for our Indian condition. And it also shows the more challenges for us for managing these crops. And of course, so farm mechanization. So nowadays, this is an era of farm mechanization where we are more concentrating on the mechanization of the farms. So the answer is there is we can see the increase in the sales of the tractors. So till now, only we have been thinking up to the level of the machineries which are used with the tractors. So that's why we can find the huge demand in the sales of the tractors, and the same may be expected in the further year also. But now, in further, I will show how the agriculture is going to be shifted from different versions. And regarding the farm mechanization, we can see what is the importance of the farm mechanization and what is the level of the farm mechanization. So you can see when we compare with our different countries, that is with US, Western Europe, or Russia and Brazil, you can see what is the workforce that has been engaged in agriculture. So earlier we used to know that we used to say that around 75% of the Indian population is working in agriculture, but we can see there is a gradual shift in the workforce of agriculture. That is, now we have came down to up to 55%. And it means that more of the labors which are available for the agriculture purpose, they have been shifted towards the other industries. That's why there is very much need for the mechanization, which avoids or which acts as an helpful hand for mechanizing the farms or mechanizing the field operations. And of course, these are the different uses of the mechanization. That is, we can, of course, we can have the save the manpower. We can finish off the hard work within the less time. And the main thing is we can reduce the input cost, because we know that nowadays, as per our Prime Minister, which he is more concentrated on doubling the farmers' income. So doubling the farmers' income, we can't say directly we can increase the output or we can increase increase the profit. But it can be doubled by reducing the input cost or cost of cultivation. So that thing has to be concentrated. So for that, the mechanization plays a very vital role. And this is the level of mechanization. You can see only for the 40% is there for the soil preparation, and 29% of the operations has been mechanized for the sowing operations, and 34% for the plant protections, 37 for the irrigations, and you can see around 60 to 70% has been they mechanized for the harvesting and threshing. So a lot of gap has been there so that we can concentrate on the mechanization. And if you see the map, we can see this is the Karnataka where we are coming under the low mechanized level. That is where we can having the mechanization from just like 40%. So this is the evolution of the agriculture which we have seen since from 10,000 BC. So if you define that as an different versions, so that is the first agriculture version one, where we are only using the manpower or animal power like that. So which is existing up to 19th century. So once there is an introduction of the machines or the introduction of the or discovery of the engines, then it starts the revolutionizing very quickly, where we can find the different agricultural machineries and the usages of the chemicals in the field. And because of the usage of the chemicals and developments of the varieties, we have seen already the green revolution. And now in the 21st century, so now we are shifting from agriculture to 3, and most of the countries they have been started the version 4, agriculture version 4, 4.0, precision agriculture. So, but in India we are in a transition period of 2.5, we can say 2.5 or 3, where we are more we need to have or incorporate these smart devices or smart systems where it is going to sense the system, it has to analyze the situation, and decision has to be taken by the system. So this comes to agriculture for which the where we can say the 3 and 4, where the more the drones have a vital role to play. And nowadays, anything which is that we have to talk about the earlier we need to we are seeing about the sustainable agriculture, but now it is an era of smart sustainable agriculture. The agriculture should be sustainable along with the smartness that needs to be added, and main aim is to optimize the production efficiency. Then whatever the quality we are getting, that should be in optimized form, and minimize the environmental impact, because this is the major thing where nowadays we need to concentrate on more. So as we know that because of this thing, we can see the Punjab farmers or the Delhi, because of the air pollution that is the news in nowadays. So these things has to be concentrated, and whatever the production associated risks are there, they should be minimized. So this is the main aim of this smart sustainable agriculture. And these are the key elements. That is, with the help of these elements only, we are able to successfully adopt this smart sustainable agriculture. That is the remote sensing, that is the data processing and management. Of course, we are using the remote sensing data by using different sources, but we need to improve the precision of the remote sensing capabilities so that we can have the different platforms, so we can use the different platforms to have more information. And cloud computing technology, telecommunications, and mechatronics, so which is very helpful for our agriculture nowadays because of the building the different kinds of robots and automation of the operations. Then these Internet of Things and artificial intelligence and robotics. So these are the different elements which is going to play a key role for successfully implementing the smart sustainable agriculture. So regarding the drones, so these things, whatever the things that has been covered, so just I'm going to skip those things, just I will glance those things. So already drone, in our mind that drone is nothing but we think that anything which is controlled or the figure which I am showing here, so that is only drone, we think that, but drone means it is, sometimes you can say that drone is you can say it's a short form of an dynamic remotely operated navigation equipment. So anything which is remotely operated without any man, so we can say that is a drone. And moreover, for our agriculture applications, we are only depending upon the drones which are going to fly. Okay. And if you see the history of the drones, how the drones has been evolved. So the first thing has been started with a small normal air balloons. So which is started in the year 1849 by the Austrians, where they used to use these drones for transporting some things from one place to other place. Then slowly it has been the role of the drones has been largely used by the US Army in the World War II, which make a significant difference with their enemies. And in the year 1922, so an first quadcopter has been invented and by a French engineer. So then around in the 83, so an unmanned aerial vehicle has been used for application of the chemicals in Japan. So they have started, so they were the pioneers in using the drones for chemical applications. And if you see this in our Indian condition, so after 2015, so this has become an very important topic or important area we can say for concentrating or for which can be used for mechanizing the things, for gathering the data, whatever the things that are there in the agriculture, we are trying to relate it with the drone systems. So how best we can use the drone system for easing our work. So we are trying to find out. And this has made an important global market for the drones, so which has been drastically increasing day by day. You can see in the year from it has been, suddenly it has been raised to 8.5 billion in 16, and it has been expected the market to be around 12 billion by 2021. So a very again it is going to change, and I think it has going to increase in an exponential form. And what are the different types of the drones which are available for our agricultural purpose? So usually the drones can be classified in many ways. So in in the simplest form, just I want to um, show you. That is, one is the, we can say it's a horizontal takeoff and landing. So it is just like an aeroplane where the takeoff and landing will be in a horizontal manner, and it is having a fixed wings. It requires a runway for the takeoff and landing. But and here the advantage is we can go for a larger mapping, then we can go for a heavier loads for the transportation purpose. But the problem is the con, we can say it is the, we can't go for a vertical takeoff. So it is very difficult for our farms in our India. So that's why, so the VTOL has came into role, that is vertical takeoff and landing, where we can hover the drone at a particular place for any time. We can fly it from one place. It can be transported from one place to other places. It can be hovered in a particular place. But here the problems is that its endurance time is very less. Its payload capacity is less compared to the XTOL drones, fixed wing drones. And again, in the VTOL, again there are different types of the single rotor, which is we call it as a helicopter. It may be a multi-rotor drone, that is a tricopter, quadcopter, depending upon the number of arms which it is having. So we can say it's a quadcopter or hexacopter and an octocopter. So depending upon the payload and the endurance time, we can select the suitable type of a drone, multi-rotor drone. So to have an advantage of HTOL along with the VTOL, so an hybrid drone has been developed where we can go for a vertical takeoff. Then it can be work for a higher speed. The cruise speed can be very high. At the same time, we can carry and we can map the larger area and carry a larger payload. So for that reason, so these hybrid drones have been developed, and in some of the research areas, there is also they are using. Then regarding the weight, based upon the weight and range of the drones, this is the classification which is has been standardized and it has been given by the DGCA. That is, then it can be classified as the nano drones, micro drones, small, medium, and large. So where depending upon the weight, where it is the less than 200 grams, so very small drones are there. So these comes under the nano drones. Then the payload capacity, including the weight of the drone, including the payload. So if it is coming up to 2 kgs, it classified as a micro, up to 25 small drones. For agriculture purpose, what we are using, so generally it will be coming for small drone side micro drones. And regarding the drone applications, so these are different drone applications, which are already some of the points has been discussed. That is the for aerial photography. So initially the drones has been used for photography only, for an entertainment purpose. Where earlier, for example, if you want to shoot a cinema, if you want to take a video from a top angle, a huge cranes has to be taken. The camera has to be mounted on it. Then the videograph has been done. But those things has been avoided, and we can use the drones in a simple manner. And regarding it can be used for shipping and delivery systems wherever is a general application where they nowadays we can see the Amazon delivery systems are there where they are using the drones for delivering the payloads. Then for geographic mapping, which can be used for our agriculture purpose. Then disaster management. So this is a major thing where the drones can play a vital role because one best example is we have used this drone in our area where near Raichur, that is Gurjapur barrage is there, where in the last year we have having a situation of a flood in the Bhima River. So we have used our drones so that we can estimate what may be the chances that how many villages may come under this flood affected system. Then we have also helped for the local authorities so that we can vacate those villages and we can avoid the mishap which has to be happened. So that has been done. And of course, there is the precision agriculture. Further, I am going to discuss about that. Then regarding the search and rescue operation, so wherever it is not possible to move in a very rough terrains and those situations, we can use the drones. We can find out the missing persons or missing animals. We can trace them easily and we can rescue them. Then, of course, for the weather forecasting, where we can go for a higher altitudes, by using the sensors, we can measure, we can estimate what may be the chances of the movement of the storms or tornadoes. So these things can be monitored, and already these things are being used in USA. Then our wildlife monitoring. So for wildlife monitoring, for monitoring the poachers from the hunting, so this has been used as an effective tool nowadays. So by having some night vision cameras and infrared cameras, we are able to identify or we can monitor the movement of the wild animals. We can monitor if there is any persons are there hiding in the bushes or somewhere, so that they can have any other actions. So these things can be monitored by the persons by sitting in a room. So these things are possible with the help of the drones. And in case of the law enforcement also, this has been especially the drones has been used in the COVID situations for monitoring the lockdown situations. So they have used the drones for monitoring the roads, and they have seen they have monitored the public, and also especially in case of the seashore line, wherever the smuggling is going to take place, very wide line and long line will be there. It's very difficult for the police to monitor those things. So it has been very helpful for the law enforcement in the seashores also. And of course, in the entertainment purpose, it can be used for an entertainment as videography, photography things. I think we have seen with around 1,500 also, we are getting a small drones so the children can play and they can have the videos and connect by connecting our simple mobiles also. So this is what I want to add extra thing. Why we have to concentrate on drones? Why the drone has came into existence when we are having the other remote sensing technologies for mapping purpose? So these are the advantages. We can say some of the pros and cons. If you having a satellite, so of course we can have an extensive coverage and wide spectral capabilities compared to drone. But the cons is we can use whatever the data we are going to get, it will be very expensive, and at the same time the resolution is very low. So resolution is very low. At max we can go for up to 50 centimeters, but usually whatever we are getting, it will be in terms of meters, 5 meters, 10 meters, 50 meters. So this kind of resolutions is very difficult for precise monitoring. And of course that there is a limitation of the time. We can't have the information whenever we want. We can have whenever the satellite is passing through that area. If suppose during that time, if it is having some cloudy weather, then gone. It will be went for other next month or next 15 days. So these things has been faced by the researchers earlier. So those things can be overcome by the drone. And of course, aircraft is also an option, but here a large single side coverage, but the resolution is high, up to 7 centimeters can be done. And here also they have used for wide spectral capabilities. But the problem is, usually there is a lot of interference of the atmosphere when we compare with the aircraft. And of course, it is a manned aircraft. And there will be a more cost is involved here. Then this is the advantages of the drone. We can have an image acquisition whenever we require. So based upon the demand of the farmer or the person, we can have the images, and resolution we can go up to 1 centimeter per pixel. So even just for 1 centimeter, whatever the variations are there, that can be observed here. And it is unaffected by the cloud cover, and it is a very cost effective compared to the other methods. But the cons are also there. That is, the area coverage will be little bit lesser compared to the other platforms, that is satellite and aircraft. And there are still the many drone regulations are coming, so which is acts as a hindrance, acting as a hindrance, because of some monitoring and some rules and regulations we need to follow. It may act as a hindrance for our drone operations. And this is a manual surveying where it is a very slow, tedious, and labor intensive, and it is very difficult to absorb and record the features by manually. So these are the potential areas. I want just to call it as a potential areas for drones in agriculture, because still in Indian conditions, we need to follow or we need to use these things in all the sectors. That is, again, apart from this, there are wide applications are there. Just I have made some broad classification. That is the soil and field analysis for seeding and planting purpose, for crop monitoring and management, for chemical spraying purpose, water management, weed mapping, crop damage and insurance, and livestock management. So if you before going for that, so this is the basic thing that has to be done for any drone data. Okay, and largely about 90 to 95% of the drone is used for as a remote sensing platform. That's why we should have these things. We should know, at least we should know what are the things are going to happen. So first of all, the data acquisition system, which is done by the drone system. Once the data has been acquired by the images, we need to go for the data set preparation. Then there again different methods are there. I'm not going to discuss these methods. So these are different methods depending upon the type of the data. This can be used for data set preparations and image pre-processing, where we are using the images and removing some of the noises or some of the errors as much as possible by using different techniques. So once those things has been done, that will be fed to the computer for artificial intelligence programs. Then again the model will be developed, which will be helpful for making some decisions. So this is the basic thing that needs to be followed. And the sensors, drone without sensors is useless for us. That's why the sensors, we can say it is a heart of a drone, which is most useful part. And again, the selection of a right sensor for the right application is very important. And as a sensor, majorly we are using the optical sensors or light sensors for acquiring the data. And we can see here at bottom, so this is the spectral range. And moreover, for our agriculture purpose, we are using the spectral range of RGB, then along with the NIR, that is the infrared region. So up to 2500 nanometers, from 400, around 350 to 400, 350 to 2500 nanometers, it is useful for our agricultural purpose. So these things, this range of spectral signatures are very important for us. So in the first is the RGB sensor. So RGB sensor is nothing but it is a simple camera, what we are using as a camera. So there is a simple RGB sensor where we are going to use some small videography drones are used. One camera will be there, which is having around the 3 to 12 megapixel camera can be used. We can take a videograph or photographs continuously with georeference points. This is important for the georeferencing is very important, and which will be helpful for taking the decisions. And based upon the different bands, so whatever the signals we have received, whatever the reflectance values we have received from red, green, and blue bands. So those will be used and calculated for calculating the different ratios. Okay, and in one of them is, I think we have heard the many kinds of the indices. That is the NDV. It may be an NDVI, it may be an RVI, it may be an green leaf index. Okay, so different indices can be calculated based upon the reflectance values. So our main objective should be, we need to try to capture the things, we need to collect the data, write signatures and write wavelength reflectance values. Then only we are able to use the data whatever we have collected. Then broadband color infrared sensors. So this is a modification of the RGB. Only we are using some filters. It may be in a band pass filters or it may be in a notch pass filters where the specific wavelength is targeted. Suppose I want to have the reflectance value of around 350 to 400 nanometers wavelength. By using those filters, we can have those values, which will be helpful for deciding the, or which is helpful for deciding the ground truth values. Then comes the multispectral sensors. So the multispectral sensors, here we are having some around 4 to 10 discrete bands. So different bands are there. We are getting the data. We can see here. So these are the data. These are the images which we are getting at different bands. So we can have see 1, 2, 3, 4, 5. Around 5 bands are there. Data are there, which is taken by this sensor, multispectral sensors. So usually we are using some. This is an MicaSense rated MX sensor, which is most commonly used. Another one is the Parrot Sequoia is there, which is these two sensors are most commonly used for having the multispectral data. And at the bottom you can see these are the reflectance values for different band lengths. Okay, and here the whatever the data we are getting, these will be a discrete data. Means for a particular wavelength, this I can say this is for 400, this may be 550, next is 700, 750, 800, like that. So for a particular wavelength, we will be getting data. But for accuracy, for accurate measuring, we need to have a continuous data which is possible with the hyperspectral sensors. So in hyperspectral sensors, we are using the hundreds of bands. So this is a bands we can see. Here we can see we can have an 100 numbers of or n number of bands. We can divide it. We can whatever the information is there, we can take out of this band. And the same graph which has been shown in the previous slide. So here we will get a continuous data. We are not having any discrete data. But the problem with hyperspectral sensors is these are very costliest sensors, and whatever data is generated, it is sorry. So whatever the data we are getting, it is a very huge data is there for handling purpose. This is an example of whatever the different crops which they are going to have the different reflectances for different wavelengths. So just as an example, this is a wheat. So wheat is very high, having a reflectance value of around 0.4 to 0.45 for a wavelength between 720 to 850. Suppose if I want to work with the wheat, then this wavelength is sufficient for me. There is no need to go for any other wavelengths. So we can have the signatures of wavelength between 720 to 850. Then we can see for the wheat stubbles, it is having an wavelength, it reacts at 1425 to 2250 nanometers wavelength. So if we are able to, by using these signatures only, we are able to differentiate whether it is a wheat or a wheat stubble, whether it is a crop or a wheat, whether it is a healthy crop or it is an infested crop. So these things can be identified by knowing these reflectance values. And of course the thermal sensors. So these thermal sensors are going to take the temperature signature. So these are the thermal sensors which are used for taking the temperature signature, where we can having different applications. That is for pest detection. It may be in livestock monitoring purpose, and of course for the crop stress monitoring. And LIDAR is another sensor where it is used for 3D mapping. And especially in our agriculture field, whenever we want to have a crop phenotyping and terrain mapping. So this will be very helpful. So just instead of going to the field and measuring the different crop parameters, just by having an surveying of that area, we can have the plant parameters in the land itself. And this is an NDVI, just to show an example for an NDVI, how it is going to calculate what is the basis for the NDVI. And the NDVI, for NDVI, we require the value of near infrared wavelength and red wavelength. So by using this formula, we are going to calculate. You can see here, this is then a healthy plant where it is going to reflect around 50% of the NIR wavelength spectrum and only 8% of the red wavelength spectrum. But if the same crop is stressed with some other things because of the browning of the leaves, we can see instead of 8%, it is going to reflect 30% of the red band wavelength and 40% of the NIR. So just by differentiating these things, we are able to develop these differences, NDVI values, and in this map we can differentiate which is the healthy crop and which is the stressed crop. And these are some of the useful spectral bands. So which are the bands are used for different monitoring systems? For example, the RGB bands are used for counting the number, the counting number of plants, modeling elevation, then visual inspection of the crops. These things can be done. If you go for an NIR, so water management can be done, erosion analysis, plant counting, soil moisture analysis, assessment of the crop health can be done. Using the red edge band, then plant counting, water management, crop health assessment can be done. And thermal infrared, we can go for irrigation scheduling, plant physiology analysis, and yield forecasting can be carried out. So these things already it has been discussed. So just I want to add again the planting for purpose already discussed. Crop monitoring and management. So here the crop monitoring and management. So the important thing is we need, once the sowing has been done, so what is happening with the crop? It can be monitored if it is a small area. If it is a thousands of acres of area is there or more area is there which is required by some organization, then the drones will play an important role. So we can have, and what is the seedling emergence rate is there, we can assess the things, what are the problem is there, we can go for pest and disease surveillance so that we can warn the other farmers to take the steps. So we can avoid the emergence of the pest in the initial conditions only. We can hold it. Then again, we can estimate the trees, number of trees, biomass estimation, it can be done. So this is an example. This is an example in case of the tea plantation. We can differentiate the soil, which is in the red, and near red and yellow, we can say this is the disease or stressed plantation, and green is the no plant stress. And we can also calculate that the diseased bush is around 6.1% of the total area. That can be estimated. And at the same time, we can also see for harvesting of the tea, which is the oldest leaf and which is the ready for the harvest, those things can be done. And this is another example. Here we can see, we can monitor whichever the areas are there, which is non-productive. That may be because of the heavy irrigations, or there may be chances of some diseases or pest, maybe infection will be there, infestation will be there. So these things can be identified just by you monitoring the crop with a drone. In this slide, we can see that you can use to count the number of trees here. So how many trees are there that can be counted and it can be classified in this manner. And regarding the water management, so just by knowing the water distribution maps, we can schedule the irrigations. By knowing the slope, we can schedule the irrigation channels and what is the slope is there. And those things will be helpful for monitoring helpful for managing the water. So because of the shortage of time, I'm going quickly. Then weed mapping. So of course, if you know the weeds, if you are able to differentiate the weeds, and once the mapping has been done, you can see here the only weeds are there, which is able to identify by finding the spectral signatures of these weeds, and we can differentiate from main crop to the weeds. Then site-specific herbicide application can be done. And of course, for the crop damage and insurance claim. So this is a very helpful. So which we have also tried to work out these things in our Raichur area also, where we have tried to find out what is the how much area has been affected by the flood, which has been affected, and the report has been also submitted. So which has been it may not be helpful now, but at least it will give an idea what is the total estimate, how much area has been damaged, and we can estimate how much loss is going to happen within a shorter period of time. And of course, the livestock monitoring. So, if it is a large herd, so livestock monitoring is very difficult. So, the livestock monitoring can be done just like counting the livestock, how much animals are there. We can monitor the body temperatures. We can separate the diseased animals from the main herd so that we can avoid the contact. We can screen the livestock and we can locate the inflammatory lesions within the body of the livestock. So, these things can also be done. And chemical spray, coming for the chemical spraying, so where is more important and we are using here. So already regarding the chemical spraying, we already know. Then just I want to differentiate why we are more concentrating on the chemical spraying apart from other applications of drone. The simple answer is it is very easy to use the drones for spraying purpose compared to the other applications. As the other applications requires, first of all, requires a highly skilled persons, high knowledge, and at the same time, it also requires more resources. But with the existing resource and within a shorter period of time, it is possible to go with a drone spraying purpose. So that's why we can see in India more research is going on with our on drone spraying only. And we can see this drone spraying is a very fast and convenient way, efficient way for applying the chemicals to the system. And main thing is no minimal exposure will be there for operator for chemicals. So this is the main thing. And automation can be done, and even distribution of the chemicals can be done throughout the field where we can expect some manual errors. So those things can be avoided here because more of these things will be depend upon the labors. We don't know whether he's going to spray the whole field or not. We can't monitor them. So those things can be avoided here. And of course, now we, as I said, less water consumption. So it requires very less water. Many of the researchers, they have tried for going for up to 10 liters or 15 liters, but as we are working out with the sprayer, so I think we need to go. We are trying with around 30 to 40 liters and up to 60 liters per hectare. So this much of per acre I'm saying 30 to 40 liters to 60 liters is the application rate what we are trying in our Raichur. And this is the status at the Raichur, US Raichur. So since from 3.5 years we are working with this one. Earlier we have started with developing from a 5-liter drone sprayer, which is a completely pilot controlled one. Then we found that as per the farmers' demand, they are saying that at least we should have the capacity of the knapsack sprayer. Then the 20 liters has been we have developed and it has been used. But again, the problem what we have faced is its time payload capacity, its balancing, then the endurance time. It came it is very less. That's why. And now currently we are much satisfied with the 10-liter capacity drones. And currently we are having two number of 10-liter drone sprayers where we are working for the different research. And we are having one RGB sensors and multispectral imaging systems where we are trying to find out the crop monitoring system. So simply the drone spray parameters. So these are the parameters which we need to concentrate more, and we need to at least as an agricultural scientist or as an agriculture graduate, where we are giving some advices for the farmers, we should know what are the parameters that we need to keep in our mind for the drone spray. That is the height of spray. What should be the height of spray, and what are the effects are there? I'm going to show the effects of those things. And in the morning session also, the lot of the doubts are there with the spray drift. Of course, there will be a spray drift. As I said, we can't avoid the spray drift. We can minimize the spray drift. Here the thing is, we can't compare the drone spraying with the aerial spraying. So as we have seen the one one hazard with an endosol farm where the aerial spraying has been done, which has been spread across the kilometers. But since with the drone sprayer, we are not going more than 3 meters height above the crop canopy. And of course, in our research, we have found out that the drone spraying height should not be more than 2 meters. It will be better. So under those situations, the drift is less. And apart from that, when flying the drones, the down drift, or we can say the downwash of the or the downforce of the air, it is also helping for proper penetration of the chemicals into the uh, plant. So we have found that in case of the drones, it is having a better coverage under the leaf compared to the top because the most of the pests are available under the leaf. So by drone sprayers, we can have a uniform coverage under the leaf because of the turbulence that is going to cause in the crop canopy. So this is regarding the application rate. So this is not important. So droplet size is an important thing, what we can see. So we have studied for the different heights. So we have found that the droplet size is going to have an inverse relation with the droplet with respect to height. So as we increase the height, the droplet size is going to decrease. And if the droplet size is very less, then more chances are there for drifting. So we need to keep the optimum droplet size. At the same time, the droplet size should not be coarse also. It should not be more than 300 or 400 microns. Otherwise, it is not possible to stick on to the pest. So that's why it should be in the range of around 150 to 300. It is better. And regarding the droplet density also, because how many number of droplets will be there on per centimeter square. So we have observed, we have taken over the leaf and under the leaf. As I said, there is no much difference has been observed from top surface to the lower surface. And of course, at the lower surface only, we have observed a better droplet distribution. And these are some of the demonstrations which has been conducted by the US Raichur. And here these demonstrations, we have not went for the farmers field. With the interest of the farmers, they have requested, and based upon that only we have covered some of these crops in their fields, and we have started working on these, and some of the data we have developed. So this is the demonstration of the drone in the paddy field. I will show the video at the last. And this is the data what we have obtained. This is an superficial data. So what I want to show, major thing is we have used the flat fan nozzle and the application rate. See, the application rate what we have used is 67 liters per hectare. Then the cost of operation was coming around 1500 rupees per hectare. And the droplet size was around 220 microns. And the field capacity was around 2.4 hectares per hour. So 2.4 hectares means it is a very large area can be covered within a less time. So similarly, the same thing can also be tried in the cotton crop also. So the similar results can also obtained here also. Then we have worked with the chili crop. So similar findings has been we have got here. Here we have changed the heights depending upon the stage of the crop because the height we can't fix exact height. The height of the crop, height of the spraying, it again depends upon the stage of the crop and type of the crop. So currently, you have tried in the groundnut crop also. At different heights we have tried. Then we have tried in chickpea. So these are the field evaluations which has been done where we are trying to find out the results with respect to different levels of concentration. So 100% concentration, then we are reducing it to 90%, 80, 75, 60, up to 50% we have reduced, and we have conducted trials. Still we are waiting for the results. And this is the method that we have used for measuring the droplet sizes. So we have used the water sensitive papers, which has been kept both on the leaf and under the leaf. And these are some of the demonstrations that has been conducted in the field. So This is a small comparison what we have done with farmers practice. That is around where the cost is coming around 600 rupees per acre. This is on the higher side only. We have then the cost saving, we can see this is important. The saving of the time is around 86% of the time can be saved, and 72% of the cost has been, 72% of the time has been saved with compared to the knapsack sprayer as well as the boom sprayer. And these are the current research activities that we are conducting in the Raichur. That is for development for the different crops. That is the cotton, chili, and paddy crops. Then we are using for this nutrient applications through foliar sprays, and we are optimizing for herbicide applications. Then optimization of pesticide chemical dosage levels we are doing for paddy, chili, and cotton crops. And these are the different benefits which I have already discussed the things. And these are the bottlenecks why we are unable to push, or these may be the reasons it is very difficult for us to to take the drone to the farmer's field directly. So these are some of the things. That is it's the flight endurance time which is very minimum. It is around only 10 minutes with one set of a battery. So these one set of battery costs around 60 to 70,000 rupees. So this is what we are facing currently. But anyhow, as the technology is coming, so the endurance time is also increasing now. And again, the initial cost, transportation. So some of the things that has been addressed by the government nowadays, and some of the still needs to be addressed. So this is the future scope. There is a need still improve. There is a need for the improvement in the drone technology, and many startup and the beginners are increasing this field. So that's why we can expect the more technology push here, and reduction in the cost may be expected in the initial cost. Then, as I said, the flight time and the range of operation may be increased, and use of the drones will grow significantly in the farming as they offer a wide range of applications in the precision agriculture. So this is all about the applications of the drone. So if any clarifications are there, then you can have it. Okay, thank you, sir. Yes, sir, of course, sir. That's what, sir. Whatever the cost of operation, what we have done. So currently, we have, yes. So currently, we are working on the different application rates also. So we have from that is the last year what we have done. So this year we have tried from 60, 40, and 20. That thing we have done, and we want to study what is the effect on the plant health also. That thing we have. Thank you.
ಬಹಳ ಚೆನ್ನಾಗಿ ತಮ್ಮ ಉಪನ್ಯಾಸವನ್ನು ಮಂಡಿಸಿದಂತಹ ಡಾಕ್ಟರ್ ಸುನಿಲ್ ಶಿರ್ವಾರ್ ಅವರಿಗೆ ಧನ್ಯವಾದಗಳು. ಈಗ IIT ವ್ಯವಸ್ಥಾಪನಾ ಮಂಡಳಿಯ ಎಲ್ಲ ಸದಸ್ಯರು ವೇದಿಕೆ ಮೇಲೆ ಆಗಮಿಸಬೇಕು. ಮತ್ತೆ ಅವ್ರ ಜೊತೆಯಲ್ಲಿ ಈಗ ಉಪನ್ಯಾಸ ನೀಡಿದಂತ ಇಬ್ಬರು ಉಪನ್ಯಾಸಕರು ಸಹ ವೇದಿಕೆ ಮೇಲೆ ಆಗಮಿಸಬೇಕು. ಲಿಯೋ ಪೀಟರ್ ಚಾರ್ಲ್ಸ್ ಮತ್ತು ಡಾಕ್ಟರ್ ಸುನಿಲ್ ಶಿರ್ವಾರ್ ಅವರು. ಸನ್ಮಾನ ಇದೆ ಅಷ್ಟೇ. ಸೊ ವ್ಯವಸ್ಥಾಪನಾ ಮಂಡಳಿಯ ಸರ್ವ ಸದಸ್ಯರು ಉಪನ್ಯಾಸ ನೀಡಿದಂತಹ ಶ್ರೀಯುತ ಲಿಯೋ ಪೀಟರ್ ಚಾರ್ಲ್ಸ್ ಅವರಿಗೂ ಮತ್ತು ಡಾಕ್ಟರ್ ಸುನಿಲ್ ಶಿಲ್ವಾರ್ ಅವರಿಗೂ ಸನ್ಮಾನವನ್ನು ನೆರವೇರಿಸಿಕೊಡ್ಬೇಕಂತ ಹೇಳಿ ಕೇಳ್ಕೊಳ್ತೇನೆ.
ಇಲ್ಲಿಯವರೆಗೆ ಏನು ನಮ್ಮ ವಿಚಾರ ಸಂಕಿರಣದ ನಿಮಿತ್ತವಾಗಿ ಚಾರ್ಲ್ಸು ಮತ್ತು ನಮ್ಮ ಶಿರ್ವಾಲ್ ಅವರು ಅತ್ಯುತ್ತಮ ಒಂದು ತಮ್ಮ ವಿಷಯ ಮಂಡನೆಯನ್ನ ಮಾಡಿದ್ದಾರೆ. ಅವರಿಗೆ ಇನ್ನೊಮ್ಮೆ ನಮ್ಮ ಕೃಷಿ ತಂತ್ರಜ್ಞರ ಸಂಸ್ಥೆ ವತಿಯಿಂದ ಹೃತ್ಪೂರ್ವಕ ಧನ್ಯವಾದಗಳನ್ನು ತಿಳಿಸ್ತೀನಿ. ಎಲ್ಲರಿಗೂ ನಮಸ್ಕಾರ. ಇನ್ನೊರು ನಮ್ಮ ಆಂಕರಿಂಗ್ ಮಾಡಿದಂತ ಅವರಿಗೂ ಶ್ರಮದವರಿಗೂ ಬಹಳ ಚೆನ್ನಾಗಿ ಮಾಡಿದ್ದಾರೆ. ಅವರಿಗೂ ಸಹಿತ ನಮ್ಮ ಕೃಷಿ ತಂತ್ರಜ್ಞಾನ ಸಂಸ್ಥೆಯಿಂದ ತುಂಬಾ ಧನ್ಯವಾದಗಳು.